Very good. So I will take the opportunity, having been given the last slot, to speculate a bit beyond my expertise. So I'm a cosmologist. I'll talk a bit about probability, though. And so Luke gave a good start. He said, good luck to those who want to do big C cosmology with Bayesian methodology. So it's something like that which I'm going to address a little bit. Probably, well, if some of you agree with me with my proposal, that'd be interesting. So let's see. First of all, what's the problem that I want to address? Well, essentially, what's a good explanation? And this is what we've sort of had quite a bit of discussion of in this meeting. So we have a situation in principle, well, okay, not necessarily now, but if we imagine a situation which we might find ourselves in, where there's finite data and underdetermination, and we wish to do inference to the best model, and that's the sort of perspective I'll take, then we're sort of naturally led to Bayesian statistics, as Luke showed us, and then we end up with the measure problem, and we have the issue of what does probability mean when we then have one observable universe? What exactly do we mean by that? And so then we ask ourselves, how do we reason rationally in this context? And what does this best model mean? So this is a bit of schematic equation. So if we think of some kind of initial conditions theory, I'll use inflation as a label for that at least. Well then, we have some posterior given some data, which means we take the likelihood and have the prior, and here I've marginalized that over some higher order laws in principle as well, so it's a kind of multiverse of some sort. And then there's the Bayesian evidence at the bottom here as well, and that's the one that I'll really focus on here. That's the one which tells us how good is whatever model we have. Okay? So as you can see, that depends crucially on that prior. So basic problem we have in principle then is that prior, whatever that is, it's not something we can test in the usual kind of way where we repeat an experiment. It's just the nature of things. We have one universe. How can we do it? And so we can't confirm it or refine it in the usual kind of way, right? So once all the data, in quotes, are collected, which, there was some discussion about this the other day. We may not get, all the data we would like to related to inflation, for instance. The Bayesian game really is the prior. I mean, if you want to really change something, unless you have some amazing new model, then it's the prior that you can work with. And that's not really something that works, because you end up just confirming whatever you want to confirm. So my point of view then is that the way in which sort of satisfactory prior can be established in this context really boils down to a kind of aesthetic choice. Either you get some output, some evidence, whatever, which you think is satisfactory, or you've got some other theoretical, structural, aesthetic motivation for why you pick whatever measure you pick. You might feel that it's natural given some context. And so this really is moving from the kind of the realm where we can think of probability as frequency of outcome into just credence in some more general sense. Okay? So then I would argue that on these grounds one could at least speculate that inflation or these kind of theories will contain, may remain to a decent degree qualitative in nature. I mean, that's the kind of situation we have with inflation at the moment. And another issue related sort of to this is, well, so one way that this is addressed in inflation, okay, so you've got some measure you want to construct and you deal with the phase space and so on. Now, someone can correct me on this or offer a different perspective, but in my perspective, I don't see a fundamental separability between that phase space description and some overarching mathematical structure kind of multiverse existence, hypothetical or not. And so how do you go about deciding sort of how you deal with that? You have a measure on the measure in a sense, and how do you address that issue, even if you can come up with a phase space measure for some case, for instance. Okay, so what I want to say by this is suggest that in some ways explanation is moving to more aesthetic types of arguments, perhaps. At least they may do eventually in this sort of scenario. And of course, one can ask, if I say this, well, okay, so is this science? I mean, this is a topic which has come up. What is it? And should we then just not say anything? Should we accept that there are limits and that's it? Or can we in some way meaningfully extend our explanatory framework? So we'll see. So just to mention some of the modes of explanation that has been brought up in the meeting, well, there's chance necessity, and there's also been elegance and beneficence. Beneficence I'll use basically as a kind of teleological kind of word, so purposeful in some sense. And so what we typically use is some combination of chance and elegance in the Bayesian framework. We've got some statistical data, we've got Occam's razor, which is sort of naturally implemented, and we've got perhaps some symmetries that constrain what the theory can be, okay? But I'll propose, and we'll see if anyone thinks, well, this is an interesting thought, a kind of axiological Bayesianism. So trying to formulate explanatory criteria in a quantitative way in analogy with the data likelihood. Okay, so if one is able to do that, and these would be perhaps other kinds of explanatory criteria that one might subscribe to. So I'm not proposing this as something which will offer you the truth, but rather if you believe in explanatory criteria X, Y, Z, what could you do with those? And then you could investigate what the support for a model would be in light of such criteria. You could also reconditionalize the probability and investigate in a different way the support for such criteria. And so the ones I'll sort of think of is evidence is the usual Bayesian thing. I'll just put these words here as a way of structuring this a little bit. Elegance, which is some kind of aesthetic criteria, and beneficence, as I mentioned, some kind of ethical or purposeful criteria. Okay? And these have come up in various talks, for instance, Don Page's talk. So how might one attempt to do something like this? Well, so probability calculus, as Luke showed you, can be derived from sort of very basic a very basic set of requirements on how to reason in the light of various pieces of information. And it's sort of one essential thing is that the inference shouldn't depend on in what order you look at things, for instance, in what order you consider data. And when I say data now, that means I'm thinking of it in a broader context then, so it could be sort of other explanatory criteria. Okay, so this leads on to measure theory, and that restricts the way that valuations can operate on sort of theory space. And it tells us how to combine different measures based on these quite simple requirements. So it tells us how to combine probabilities. And so in principle, such a construction would allow us to generalize probability to any measure defined on some lattice. And so think of this as a lattice of theories. There's an empty set, there's some foundation elements, and then you just combine all the combinations, basically. Okay? So if we meaningfully can represent theories on some kind of lattice like this, and we can assign valuations that seem meaningful given some criteria, well then, okay, we could come up with a kind of probability equivalent measure. And then this would be combined with the usual data likelihood in the sort of expected way. You would just multiply them together. That's what the construction tells us we ought to do with measures. So one could then construct a kind of generalized Bayesian evidence in this way, combining all different ones together. So looking at this, as you can see, it's kind of like proposing a way to assign a theory prior. That's one way of looking at this. And so we have in a more sort of formal sense, roughly speaking, we have a direct product space of data, aesthetics, and ethics, as in the way that I've described this, at least. Okay. So one surely would ask if this is not a bit problematic, because it seems to be just introducing arbitrary value in some way. Now, obviously, in general, I would say that's problematic, but now we're trying to address the issue of what do we do when there's no more information, if we are in that situation. Can we do anything if we want to have a best model? Well, we can be clear about things, is what I think. But okay, a physicist might say, well, it's not science, it's just meaningless, this is completely untestable, so let's forget about it. Well, fine, yes, let's that's fine. A philosopher might say, well, this is, and yeah, probably other things too, but you can't quantify this, and it's, you can't say that this is some kind of answer. The real, it's not reality it's not truth. But I would guess point out that these are relative comparisons and it's conditional on whatever criteria you propose. And I guess one of the main points here is arguably people do make such assumptions and use such ways of thinking. And so perhaps this is a kind of attempt to be clear about that, or try to be rational, at least in view of the fact that we do function that way. The other way, of course, is staying silent. So one thing that kind of construction opens a possibility for is some kind of multi-explanatory scenarios. So you could imagine that you can have a situation where some separate pieces of explanation don't offer really a good explanation, but jointly perhaps that jointly they would offer a good explanation in someone's view. Now that has problems with it, I think, still, but it could be an interesting construction to consider. One can also look at the consistency between data and different criteria, so you can form different combinations basically and see how they sort of match together. That's the kind of thing you can do. So just to make it a little bit concrete, you could do the individual evidences evidence, elegance, beneficence for a particular model. Well, what you want to really do is model comparison. So I've just tried to construct some publicity images, which might give an idea of how this could work in practice. So you'd calculate this individual evidence, elegance, beneficence values plotted along some axis here, and then you could compute the sort of two-dimensional ones, these areas here, and then the sort of three-dimensional one, and then you could relate those to each other and see what they tell you about your model in comparison to the other, of course, in this case. What would be needed to make this kind of construction work? One would need, of course, foundation elements for these lattices of models, how to represent them, some aesthetic measure on the theory space, equally some kind of ethical measure on the possibility space, and then computational capability to actually evaluate this, because I think that may be one limitation in this. So possible areas which might be relevant for these considerations, well, computational complexity theory in the context of the possibility space, perhaps also the aesthetic qualities. There's also experimental and computational inference aesthetics, which tries to address some of these criteria. And so, well, that's a bit of speculation. Right, so to summarize, really, what I propose is that the conventional model inference for initial conditions in such higher order questions is plausibly a qualitative exercise to at least a good degree, given the fact that we have this one universe problem. That's the whole thing, right? And that the measure problem goes beyond phase space because of this qualitative property, and you in principle have the problem of measure on the measure on the measure, because we are limited in this information. So this this situation suggests that we either should restrict what we talk about completely and just stick to what we can say anything about for sure, in the sense of empirical data, or we could attempt to extend the explanatory framework to take into account other kinds of explanatory criteria. And so I propose a kind of possible approach that one could try to do this based on just extending the measure theoretical probability definition. And then you can compute these sort of evidences. Whether this is a good idea, whether it could be made useful, I really don't know. But I think at the least it might be a useful thing to consider and think about for, well, considering the problems we do have to face in this context when it comes to what we mean by probability, what we mean by explanation. And if nothing else, it can help us make our statements and claims a bit clearer. Thank you.
Thank you, Martin. So we have just a few minutes for questions. Yeah. Brian?
Brian Pitts. I wonder if you might find it fruitful to take a look at Patrick Maher's work, which takes into account utilities in accepting scientific theories. I'm not sure if there's a similarity, but it might be. It's Bayesian plus in some sense.
Okay. Okay, I'm not familiar with this. Thank you.
Any more questions? We're running a bit late, so I think maybe I'll just thank you very much indeed.
Okay, thank you.
I was forgetting the... Well.